Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions of the Corbettmaths Practice Questions on relative frequency. If you need any extra help on relative frequency, if you go to Corbettmaths and go to the videos and worksheets section, and scroll down to video number 248, there's a dedicated video tutorial there on relative frequency. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions of the practice questions, so let's get started. Okay, question 1. Question 1 says that Jordan throws a ball at a target 10 times and he records his results as H, which stands for hit, or M, which stands for miss. So here are his results: hit, miss, 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 hit, miss, hit, miss, miss. And the question says write down the relative frequency of Jordan hitting the target. So to find the relative frequency of Jordan hitting the target, we need to see how many times he hits the target and then write that as a fraction out of how many times he threw the ball at the target. So that would be, he hit the target once, twice, 3 times. So he hits it 3 times out of the 10 throws. So that means the relative frequency of Jordan hitting the target would be 3 attempts, 3 out of 10. He hit it on 3 of the 10 attempts. And that's it. Okay, let's look at our next question, question number 2. So question number 2 says the spinner is spun 100 times and it lands on blue 19 times. And we've been asked to write down the relative frequency of the spinner landed on blue. So again, to find the relative frequency of the spinner landed on blue, we need to write down how many times it lands on blue over how many times the spinner was spun. So that would be it lands on blue 19 times, that's 19, out of the 100 times that it's spun. So that means the relative frequency of a blue would be 19 100ths. It landed on it 19 times out of the 100 spins. And that's it. And that fraction can't be cancelled down, so I would just leave it like that. Okay, let's have a look at our next question, question number 3. So question number 3 says Matilda rolls a dice 60 times and the table shows the results. So we've got the number on the dice, 1, 2, 3, 4, 5 and 6, and the frequency, 15 ones, 9 twos, 8 threes, 10 fours, 13 fives and 5 sixes. And the question says what is the relative frequency of a 2? So to find the relative frequency of a 2, we just need to write down how many times the dice landed on a 2, which is 9 times, out of the number of times the dice was rolled, which is 60. So that means the relative frequency of a 2 would be 9 60ths. It landed on a 2, 9 out of the 60 rolls. Now that fraction can be cancelled down. Both of those numbers are divisible by 3. If we divide both the numerator and the denominator by 3, we would get 9 divided by 3 is 3, and 60 divided by 3 would be 20. So that means the relative frequency of a 2 would be 3 20ths. Now in this question we weren't told to cancel down the relative frequencies. You could leave it as 9 60ths and that would be totally fine as well. Okay, let's look at our next question, question number 4. So question number 4 says, Josie wants to test if a coin is biased. She flips the coin 30 times and here are the results. So we've got head, tail, head, tail, head, to head, tail, head and so on. And part A says complete the relative frequency table. So we want to complete this table. So we've got heads, tails and the relative frequency of each of them. Notice it's relative frequency and not frequency. So let's start off by writing down how many times it lands on heads and how many times it lands on tails. So in terms of heads, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So it lands on heads 22 times. In terms of tails, it lands on tails 1, 2, 3, 4, 5, 6, 7, 8 times. And let's just check. The question did say it was flipped 30 times and 22 plus 8 is 30. That's fantastic. So we've got the frequencies. Now let's write down the relative frequencies. So the relative frequency of a head would be 22 out of 30 because it landed on heads 22 times out of the 30 flips. Now that can be cancelled down. Both of those numbers are divisible by 2. So we could divide both the numerator and denominator by 2 and we get 11 fifteenths. So that means the relative frequency of heads would be 11 fifteenths. You could write 22 30ths, that would be fine as well. And the relative frequency of tails, well, how many times did it land on tails? 8 out of the 30 flips. So again, you could write 8 30ths there, but I'm going to cancel it down. If we divide both the numerator and denominator by 2, we get 4 fifteenths. So that means the relative frequency of tails would be 4 fifteenths. And that's it. So we've completed the relative frequency table. And then if we go down to part B says, do you think that the coin is biased? Explain your answer. So the coin is flipped 30 times and it lands on heads 22 times. If this was a fair coin, you would expect it to be, well, hopefully 15 heads and 15 tails. Perhaps 16 heads and 14 tails, or 17 heads and 13 tails, but 22 heads and 8 tails seems quite skewed. It actually seems if heads comes up a lot more than it should do. So I'm going to say yes, I do think the coin is biased. I think it's biased towards heads because it landed on heads a lot more times. Now obviously you could say potentially here no, you could say that you don't think the coin is biased because you could say that 30 flips isn't that many and it could land on heads 22 times and a fair coin could land on tails 8 times. But obviously with it just being 30 flips, that's not actually a very big number. So you could actually argue either way. You could say yes, it's biased because it's landed on heads a lot more times than you would expect. Or you could say actually that the coin hasn't been flipped that many times. So you can actually choose which one you want to go for here. I'm going to go for yes because I think it's landed on heads a bit too many times. So I'm just going to explain that. And that's it. I've just explained that yes, the coin should have landed on heads 15 times and 22 is a lot higher than this. And then if we go down to part C says that Josie decides to flip the coin 150 times. Calculate an estimate of how many times the coin should land on tails. So if we go up here, it was flipped 30 times. So we've got here flips. So here we've got flips and I'm going to write tails. So the coin was flipped 30 times to begin with and it landed on tails. It landed on tails 8 times. So that means if she flipped it 150 times, so if she flipped the coin 150 times, which is 5 times greater, you'd expect 5 times as many tails. So 8 times 5 is equal to 40. So because she's flipped it 5 times more, you would expect it to be 5 times as many tails. So we've just done 8 times 5, which is equal to 40. So that's how many times I would expect that coin to land on tails. And that's it. Another way you could have done that question would be to find the relative frequency of it landing on tails, which was 4/15. And you could do 4/15 off 150, how many times she's going to flip it. And if you divide by the bottom times by the top, you get 40 as well. Okay, let's have a look at our next question, question number 5. So question number 5 says, Kevin rolls a dice 30 times, and these are his results of 3, 4, 4, 4, 6, and so on. And part A says complete the relative frequency table, so we want to complete the relative frequency table here. So what I'm actually going to do is I'm going to write down the frequencies. So we've got 1, 2, 3, 4, 5, and 6, and I'm going to write down the frequency of each of them to begin with. So in terms of the frequency of a 1, we've got one of those, just 1, 1, and then a 2, we've got 1, 2, 3, 4 2s. Any more? Nope. So 4 2s. 3s. 1, 2, 3, 4, 5 3s. 4s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 4s. 5s. 1, 2, 3, 4, 5 5s. And 6s. 1, 2, 3, 4, 5. And let's just check that. 1 plus 4 is 5, plus 5 is 10, plus 10 is 20, plus 5 is 25, plus 5 is 30. And that's fantastic. It was rolled 30 times. So in terms of the relative frequencies, the relative frequency of 1 would be it landed on 1 once out of the 30 times, that's 1/30th. It landed on a 2 4 times, that's 4 out of 30. It landed on a 3 5 times, that's 5/30ths. It landed on a 4 10 times, that's 10/30ths. It landed on a 5 5 times, that's 5/30ths, and it landed on a 6 5 times, that's 5/30ths. Now these fractions, I'm going to cancel them down. The relative frequency of 1 is 1/30th. The relative frequency of a 2, you could write as 4/30ths. You could actually write these all as 30ths if you wanted to. It didn't say you had to cancel it down, but I am. They're both divisible by 2, so I'm going to write there 2/15. In terms of the relative frequency of a 3, that's 5 out of 30, 5/30ths. So if we can divide both of these by 5, we would get 1/6. Here we've got the relative frequency of a 4 being 10/30ths. They're both divisible by 10, so that'll be 1/3. And then it would be 1/6 again and 1/6 again. So they're the relative frequencies. And then part B says, do you think the dice is biased? Well, it landed on a 4 10 times and it only landed on a 1 once. I think that's a lot in terms of if you roll it 30 times to get 10 number 4s and only 1 number 1, I think that dice is a bit biased. That's my opinion. Now again, you could argue that it's only been rolled 30 times and it needs to be rolled more to get more reliable results, but I think that 10 times as many 4s than 1s shows the dice is probably biased, so let's explain that. And that's it. I've just explained that yes, I do think the dice is biased because the dice landed on a 4 10 times more frequently than a 1. And that's it. And then if we go down to part C said that Kevin decides to roll the dice 600 times. Calculate an estimate of how many times the dice would land on the number 4. So we want to find out how many times the dice should land on the number 4. So there's a couple of approaches we could use. The relative frequency of a 4 is equal to 1/3. So that means that a third of the times it's going to land on a 4. So we could do 1/3 of 600. And if we do a third of 600, that tells how many times we'd expect it to land on a 4. And a third of 600, well, dividing it by 3 would be 200. So we'd expect it to land on a 4 200 times. And that's it. Another way to do it would be to say rolls and 4s. So if we go up, it was rolled 30 times. So it was rolled 30 times originally, and it landed on a 4 10 times. So if it's rolled 600 times, which is 20 times more, you'd expect 20 times more 4s, or 20 times as many 4s, and 10 times 20 is equal to 200. So again, it's equal to 200, and that's it. Okay, let's look at our next question. So question number 6 says a bear's coin is flipped 20 times. So the coin's flipped 20 times, and it lands on tails 5 times. And the question says to write down the relative frequency of the coin landing on heads. So we're looking to find out the relative frequency of the coin landing on heads. So if the coin lands on tails 5 times, the rest of the times it must land on heads, because it's either going to land on heads or tails. So if we take 20, the number of times the coin was flipped, and we subtract 5, the number of times the coin landed on tails, the answer would be how many times the coin landed on heads. And 20 subtract 5 is equal to 15. So that means the coin landed on heads 15 times. So if we wanted to know the relative frequency of the coin landed on heads, well, we're going to do 15 out of 20, the number of times it landed on heads, over the number of times the coin was flipped. So that means the relative frequency if the coin landed on heads is 15/20. Now you could leave your answer like that if you wanted to. I'm looking at this straight away and seeing it can be simplified. So if we divide both the numerator and denominator by 5, 15 divided by 5 is 3, and 20 divided by 5 is 4. So it means the relative frequency if the coin lands on heads is 3/4. It lands on heads 3/4 of the times. So 3/4, and that's it. Okay, let's look at our next question, question number 7. So question number 7 says, Omar and Kate want to work out the probability that a bass coin will land on heads. Omar flips the coin 20 times and it lands on heads 17 times. And Kate flips the coin more times, she flips it 60 times and it lands on heads 50 times. And the question says, write down the relative frequency of the coin landing on heads based on Omar's results. So Omar flipped the coin 20 times and it landed on heads 17 times. So the relative frequency of heads would be 17/20. 17/20. And then if we go on down, we're then asked to find the relative frequency of the coin landing on heads based on Kate's results. Well, she flipped the coin 60 times and it landed on heads 50 times. So the relative frequency of the coin landing on heads would be 50/60. Now that can be cancelled down, both the numerator and denominator divisible by 10, so that would be 5/6. So that's it. So the relative frequency of the coin landed on heads based on Omar's results would be 17/20, and based on Kate's results would be 50/60. That's fine, or 5/6. Okay, if we go on down, part C says whose results will give a better estimate for the probability of the coin landing on heads? Explain your answer. Now, if we want a more accurate result, if we want a better estimate, you want to do the trial or the experiment as many times as possible, because the more times you do it, the more accurate your results will be. So that means that Kate's results would be the better estimate because she done the experiment 60 times. She flipped the coin 60 times, whereas Omar only flipped it 20 times. So let's explain that. And that's it. So just written down Kate's results because she completed more trials. She done the experiment more times. She flipped the coin more times. So her estimate's going to be better than Omar's because he only flipped it 20 times. Okay, let's look at our next question. So question number 8. So question number 8 said, David and Becky want to estimate how many yellow jelly beans are in a tub of 500 jelly beans. There's 500 jelly beans in a tub, and a trial consists of taking a jelly bean at random, noting the colour, and then putting the jelly bean back into the tub. So they're just randomly picking out jelly beans, looking at them and putting them back in. Obviously probably mixing them all up before taking each one out. And then we've got here David, number of trials. So how many times did he do this experiment? 20 times. And the number of times that he chose the yellow jelly bean was 3 times. And then Becky done it more times. She done 100 times. She done 100 trials. So she took out the jelly bean 100 times and she got a yellow jelly bean on 11 occasions. And part A says, write down the relative frequency of David taking a yellow jelly bean. So he done the experiment 20 times and he got a yellow jelly bean on 3 occasions. So the relative frequency of David choosing a yellow jelly bean would be 3/20. 3/20. And then part B says write down the relative frequency of Becky taking a yellow jelly bean. So she done the experiment 100 times and she got a yellow jelly bean on 11 occasions. So the relative frequency of Becky picking a yellow jelly bean would be 11/100. And that's it. And then if we go on down, part C says, whose experiment will give a more reliable estimate of the number of yellow jelly beans in the tub? Give a reason for your answer. So this is a bit similar to the last part of the last question. So this is quite common in relative frequency questions where you're asked whose results would give you a better estimate. And it's going to be the one who does the experiment on more occasions. So who done it more often? So if we have a look here, David only done 20 trials, whereas Becky done 5 times as many. She done 100 trials. So her estimate's going to be more reliable than his because she done the experiment more times. Because the more times you do something, you get a better picture of what's happening. So that means that her results are more reliable. So let's explain that. And that's it. I'm going to just explain that Becky's experiment as she's completed more trials. She's done this experiment more times, so her results would give us a better estimate of how many yellow jelly beans are in the tub whenever she works it out. Okay, let's have a look at our next question. So question number 9 says, a spinner is spun 200 times and the relative frequency of an orange is 0.3. So there must be an orange section on the spinner. And the question says, how many times has the spinner landed on orange? So if we want to work out the relative frequency, what we do is we take the number of successes and put that over the number of trials. If you times the relative frequency by the number of trials, you get the number of successes. So if you times the relative frequency of an orange, so 0.3, by the number of times the spinner is spun, which is 200, the answer will tell us how many times the spinner landed on orange. So in other words, how many successes it would be. So if you just times the relative frequency by the number of times the experiment is carried out, the answer would be how many times that event took place. So we would do 0.3 times 200. And when we do on our calculator, 0.3 times 200, that's equal to 60. So it means that the spinner landed on orange 60 times. And that's it. And you can check your answer. If you do 60 over 200 as a fraction, that would be the relative frequency. And if you cancelled that down, you'd get 3/10, and 3/10 is 0.3. So that would give us the right relative frequency. So if you times the relative frequency by the number of times the experiment takes place, that'll give you the number of successes. So how many times does, in this case, the spinner land on orange? Okay, let's look at our next question, question number 10. So question number 10 says, a coin is flipped 50 times and Molly records the results and says the relative frequency of tails is 0.85. And the question says, explain why Molly is incorrect. So if we times the relative frequency, the 0.85, by the number of times the experiment is taken place, so in this case 50, that should tell us the number of times that the coin lands on tails. So if we do 0.85 times 50, that's equal to 42.5, 42.5. Now, the coin can't land on tails 42.5 times. That doesn't make sense. So the relative frequency can't be exactly 0.85. Perhaps it's something slightly different. So the question says, explain why Molly's incorrect. Well, the coin can't land on tails 42.5 times. So let's explain that. And that's it. I've just explained that 42.5 tails is not possible. So the relative frequency of 0.85 is not possible. So it's not possible if I get a relative frequency of 0.85 if she flips the coin 50 times. Okay, let's have a look at our next question, question number 11. So question number 11 says, a spinner lands on white, black, red or orange, and the relative frequency after 120 spins is shown in the table. So we've got the relative frequency of each of these colours. So the relative frequency of a white is 0.25, of a black is 0.4, of a red is 0.2, and of an orange is 0.15. And the question says, how many more times did the spinner land on white than orange? So we want to find out how many more times it's landed on white than orange. So let's work out how many times it landed on white. Let's work out how many times it landed on orange, and then take them away to see how many more times the spinner landed on white than orange. So to find how many times the spinner landed on white, we're going to take the relative frequency, the 0.25, and we're going to times that by the number of times the experiment took place, or in this case, the number of spins, which is 120. And if we do 0.25 times 120, that's equal to 30. So it landed on white 30 times. So that's how many times the spinner landed on white. Now, in terms of orange, we're going to take the relative frequency, which is 0.15, and we're going to times that by the number of times the spinner was spun, which is 120, and that's equal to 18. So that means the spinner landed on orange 18 times. So if we want to find out how many more times the spinner landed on white than orange, we're just going to do 30 subtract 18. And 30 subtract 18 is equal to 12. So the spinner landed on white 12 more times than it landed on orange. And that's it. Okay, let's have a look at our next question, question number 12. So question number 12 says a three-sided spinner is labelled A, B and C. So we've got this three-sided spinner and it's labelled A, B and C. And the spinner is spun and the frequency of the letter A is recorded every 10 spins. So every single 10 spins, they write down the total of the number of times that it's landed on A so far. So after 10 spins, it landed on A 5 times. After 20 spins, it landed on A 12 times altogether. After 30 spins, it landed on A 21 times. And after 40 spins, the total number of times that it landed on A is 26 times. And part A says, plot the relative frequencies on the graph below. So quite often with relative frequencies, there'll be a graph and you'll have to maybe plot the relative frequencies on a graph and draw the graph to show them. So let's do that. So if we have a look at the graph, we've got relative frequency going up the vertical axis and the number of spins going across the horizontal axis. And it's going 0, 10, 20, 30, 40, 50, and so on. Okay, so if we go back up, okay, so let's find the relative frequency of an A after 10 spins, 20 spins, 30 spins, and 40 spins, because we've got the frequencies, but it'd be great if we had the relative frequencies. So in terms of the relative frequencies, after 10 spins, it landed on A 5 times. So the relative frequency of an A would be 5 over 10. Or 5/10. Now that could be cancelled down, but actually I'm just noticing here we've got decimals going up the vertical axis, so I'm going to actually change these relative frequencies from fractions to decimals. So 5/10 would be 0.5. And remember, it's a calculator question, so you could just type in the fraction and then just convert that into a decimal, or divide the numerator by the denominator. Okay, next, after 20 spins, it landed on an A 12 times out of the 20 spins, so the relative frequency would be 12/20. Again, that could be cancelled down to be 6/10, which is 0.6, or you can just type into your calculator and change it into a decimal to be 0.6. Okay, next, after 30 spins, it lands on an A 21 times, so the relative frequency at that point of an A would be 21 out of 30. That could be cancelled down to be 7/10, and then change the decimal to be 0.7, or again, you could just type that into the calculator and convert it to a decimal to be 0.7. And finally, after 40 spins, the relative frequency of an A would be 26 out of 40. And then again, you could cancel that down to be 13/20, which is 0.65, or you could just type it into the calculator and then change it to a decimal to be 0.65, or do remember the numerator divided by the denominator. So if you do 26 divided by 40, you get 0.65. So that's fantastic. We've now got the relative frequencies. So let's plot them. After 10 spins, the relative frequency of an A was 0.5. So half of the times it landed on A. So that's 0.5. After 20 spins, if we go up here, we've got 10, 20, 30, 40. So after 20 spins, the relative frequency of an A is 0.6. So 20 spins, 0.6 would be there. After 30 spins, the relative frequency is 0.7. After 40 spins, the relative frequency of an A is 0.65. So 0.6, 0.7, 0.65 would be in the middle there, 0.65. So we've plotted those 4 points. Now we're just going to join them up. And that's it. So we've plotted the relative frequencies and we've joined them up. Okay, and then if we have a look at part B says that Neil says the relative frequency after 50 spins is 0.8. Explain why Neil is wrong. So he's saying that the relative frequency after 50 spins is 0.8 and explain why he's wrong. Okay, so if we go back up here to the table, I'm just going to move some of this working out. Just going to move that over there and that down there. So what Neil is saying is that after 50 spins, the relative frequency is 0.8. So what I'm going to do is I'm going to work out, if it was 0.8, how many times would the spinner had landed on A. So if we take the relative frequency, so we go back down here, if we take the 0.8 and we multiply that by 50, how many times would the spinner land on A? So if we do 0.8 times 50, it's a calculator question, that's equal to 40. So that's saying that the spinner has landed on A 40 times. So if we go back up, Neil is saying after 50 spins that the spinner has landed on A 40 times. Now that's not possible. Now if we have a look here, after 40 spins, the spinner landed on A 26 times. And then by 50 spins, it's been spun 10 more times, so it's been 10 more spins. But if it's been spun 10 more times, you can't have an extra 14 A's. It can't increase by that amount. It can only actually increase by a maximum of 10. If it landed on A every single time that spinner was spun, you would have 36 A's. But you couldn't have 40, that's too many. So it can't actually then be 40 out of 50, because if it's landed on A 26 times out of 40, the maximum number of times it could land on an A out of 50 spins would be another 10 spins, so that'd be 36 times. So it can't actually be 40. So that's it, so let's explain that. And that's it. So I've just explained that 0.8, the relative frequency that Neil's claiming, multiplied by 50, the number of spins, would mean that there's 40 A's. But the spinner had 26 A's after 40 spins. So with 10 more spins, because it had 40, with 10 more spins to get to 50, a total of 40 A's is not possible. It can't go from 26 A's up to 40 A's in 10 more spins. And that's it. So Neil is wrong. Okay, let's have a look at our next question. Okay, so question number 13. Question number 13 says a spinner can land on A, B, or C. So this spinner can land on A, B, or C. And Megan spins the spinner 800 times. And she notices that the relative frequency of a B is 0.25 and the relative frequency of a C is 0.41. And the question says how many times did the spinner land on A, or work out how many times the spinner landed on A. So in this question, there's a few approaches that we could use. We could use the fact that if the spinner is going to land on either A, B, or C, that all the relative frequencies of A, B, and C will have to add together to be 1. You could add together the two relative frequencies for B and C, and that's equal to 0.66. Take that away from 1 to be 0.34, and then times it by 800 to see how many times the spinner landed on A. So that's one approach. The other approach, and this is the approach that I used whenever I'd done the answers on the website, was to actually consider the B's to begin with. So in terms of the B's, the relative frequency of a B is 0.25. And the spinner is spun 800 times. So if we multiply the relative frequency by the number of times the spinner is spun, that'll tell us how many B's Megan got. So 0.25 times 800 is equal to 200. So that means that it landed on B 200 times. In terms of the letter C, the relative frequency of the spinner landed on C was 0.41, and we multiply that by the number of times the spinner was spun, which is 800, and when we do that we get an answer of 328. So that means the spinner landed on a C 328 times, just timesing the relative frequency by the number of trials. So that's fantastic. We now know how many times the spinner landed on B, 200. We know it landed on C, 328 times. To work out how many times the spinner landed on A, we just need to then add them together. So 328 plus 200 is equal to 528. And then take that away from 800 because it was spun 800 times. So 800 subtract 528 will be equal to 272. And that's it. So that means the spinner landed on A 272 times. So that's it. So how many times did the spinner land on an A? The answer is 272. Okay, let's have a look at our next question, question number 14. So question number 14 says a spinner has got 4 sections and they're labelled A, B, C and D. And Susan and Helen spin the spinner a number of times. So Susan spins it 20 times and Helen spins it 120 times. We're told that Susan lands on a B on 8 occasions. So her spinner lands on a B on 8 occasions. And we want to find the relative frequency for Susan. And for Helen, we want to find out how many times her spinner landed on a B. So let's start off with Susan and find the relative frequency of her landing on a B. So she spun the spinner 20 times and it landed on a B on 8 occasions. So for Susan, the relative frequency of a B would be 8/20ths. Now that could be cancelled down. We could cancel it down to be, both of them are divisible by 4, so that could be cancelled down to 2/5. Could be even written as a decimal number, as 0.4, however you prefer. The question doesn't actually say that you have to cancel it down, so you could just leave it as 8/20ths. In this case, I probably would have written 0.4 just because the other one was given as a decimal, but it doesn't say you have to do that. Okay, so that's part A. So we've got that the relative frequency of Susan obtaining a B was 8/20ths, or 2/5, or even 4/10ths, or 0.4. Now let's have a look at Helen. So for Helen, we know that Helen spun the spinner 120 times and the relative frequency of her getting a B is 0.35. So if we take the 0.35 and multiply that by 120, that'll tell us, if we multiply the relative frequency by the number of trials or spins, that'll tell us how many successes. That'll tell us how many times the spinner landed on a B. So 0.35 multiplied by 120 is equal to 42. So that means that it landed on a B 42 times. And that's it. Let's have a look at our next question, question number 15. So question number 15 says a spinner has got a green section and a blue section, and the spinner is spun 500 times. And the table shows the relative frequency of a green after different numbers of spins. So after 100 spins, the relative frequency of a green is 0.12. After 400 spins, the relative frequency of a green is 0.23, and so on. And the question says, how many times was a green obtained after 400 spins? So to find out the number of successes, in other words, how many times the spinner lands on green, we just take the relative frequency. That says 400 spins, so we're looking here. We take the relative frequency, which is 0.23, and we multiply that by the number of trials, or in this case, the number of spins. So we just need to do 0.23 times 400. Now this is a non-calculator question. So what I'm going to do here is, rather than times by 400, I'm going to times by 100 and then by 4. Because if you multiply by 100 and then times by 4, that's the same as multiplying by 400. So 0.23 times 100 would be equal to 23. And then we're going to do 23 times 4. And to do 23 times 4, you double it and double it again. So double 23 would be 46, and double that would be 92. So that would be 92. So how many times was a green obtained after 400 spins? The answer would be 92. Now I just want to mention with this multiplication, I done 0.23 times 400 by timesing by 100 and then timesing by 4. There's other ways you could do it. You could do 23 times 400 and then just get your answer and then just divide by 100 at the end, because obviously if you're multiplying by 23, you could then just divide that by 100 to get the answer to this multiplication, and so on. And that's it. Okay, let's look at our next question, question number 16. So question number 16 says, there's 50 sweets in a jar, and in a trial, a sweet is chosen at random and then it's replaced. So they take a sweet out at random and then they put it back in again. And the results are recorded every 20 trials. So every 20 trials, the result is recorded. And the graph shows the relative frequency of a blue sweet. So we've got here 20 trials, then 40, 80, and 100. 40 seems to be missing here. Let's go on down. We're told in the first 40 trials, 10 blue sweets were chosen. Plot this result on the graph. Okay, so we need to plot this result on the graph. So it says in the first 40 trials, 10 blue sweets were chosen. So let's write down the relative frequency of a blue. So it'll be out of 40 because there's 40 trials and there was 10 blues, so that's 10 out of 40. Now 10/40ths is the same as 1/4, and if we go up in the vertical scale, the relative frequency is given as a decimal and 1/4 is 0.25. So that means that after 40 trials, the relative frequency of a blue is 0.25. So we've been asked to plot that on the graph, so let's go to our graph. And we go across the 40 and we go up to 0.25, which would be here in between 0.2 and 0.3. So that would be there. So that's that point plotted. And then we've been asked, part B, what is the best estimate from the graph of the probability of a blue sweet? Explain your answer. So we want to find the best estimate of the probability of choosing a blue sweet. So remember we talked about earlier, whenever you do the trial the highest number of times, it gives you more reliable results. So in terms of the results, the result with the highest number of trials would be this one, the one with 100 trials. And the relative frequency is 0.3. Now obviously it's 0.3 because it's an experiment, so it's the relative frequency, but that would also be our best estimate in terms of the probability. So if we were to estimate the probability of getting a blue sweet from this jar, it would be 0.3. So it's the one with the highest number of trials. So let's explain that. And that's how I've just explained that the result of 0.3 is the best estimate of the probability when the 100 trials were carried out, because it's the result with the most trials. And then if we have a look at part C says use your answer to estimate the number of blue sweets in the jar. So let's go back up to our question a moment. We're told there's 50 sweets in a jar, so there's 50 sweets in a jar, and we've been asked to estimate the number of blue sweets in the jar. Now we have just worked out the estimate of the probability to be 0.3. We've said the probability of choosing a blue sweet is going to be 0.3 by using our estimate based on the highest number of trials. So the probability of a blue is equal to 0.3. And there's 50 sweets in the jar. So that means that 0.3 or 30% of them will be blue. So if we take 0.3, the probability, and times that by the number of sweets in the jar, that'll tell us how many blue sweets should be in the jar. So 0.3 times 50, well 3 times 50 is 150, so 0.3 times 50 would be 15. So our estimate for the number of blue sweets in the jar would be 15, because the probability of choosing a blue sweet we estimated to be 0.3 or 30%. There's 50 sweets in the jar, so that means that 30% of them should be blue, and that would be 15. Or you take the probability, which is 0.3, you times it by the number of sweets in the jar, which is 50, and you get 15 as well. So the answer would be 15. And that's it. Okay, let's have a look at our next question. Question number 17. So question number 17 says, James has a box that contains 4,000 Lego bricks, and he wants to know the probability of picking a white Lego brick. He picks a brick at random and then replaces the brick in the box. He does this 50 times and calculates the relative frequency of a white after every 10 trials. So after 10 trials, the relative frequency was 0.3, so that means that he must have 10 times 0.3 is 3. So that means he selected 3 Lego bricks out of the first 10, and so on. And then part A says, says, use the graph to calculate the number of times James chose a white breaker in the first 10 trials. Okay, so if we have a look at the first 10 trials, the relative frequency of a white was 0.3. He took bricks out 10 times. So if we do 0.3 times 10, the number of trials, that gives us the number of successes. 0.3 times 10 is equal to 3. So he selected 3 white bricks in the first 10 trials. And then part B. Part B says, what is the best estimate for the probability of choosing a white brick? So if we want to find the best estimate of the probability of selecting a white brick from the box, what we need to do is just find the relative frequency with the highest number of trials, because it'd be the most reliable result. So it'd be this one here. So that is equal to, the relative frequency is 0.2. So that means that our best guess for the probability of selecting a white brick would be 0.2. So let's write that down. And that's it. I've just explained that our best estimate in terms of the probability of selecting a white brick would be 0.2, because that's when 50 trials were completed, and that's the most number of trials that were carried out, so it's the most reliable. Okay, let's have a look at our next question, question number 18. So question number 18 says, on Saturday, Edward writes the first 400 words of a story, and he spells 392 words correctly and 8 words incorrectly. And on Sunday, Edward writes the remaining 1,600 words of the story. And for the entire story, the relative frequency of a word being spelled incorrectly is 0.013. And the question says, what percentage of the 1,600 words written on Sunday were spelled correctly? Okay, so let's have a look at this question. So he wrote 400 words on Saturday, and then the next 1,600 words on Sunday, and he wrote the whole story. We're told that the relative frequency of him spelling a word incorrectly is 0.013 over the whole story, over the entire story. So if we take 2,000, the number of words altogether, adding together 400 plus 1,600, that's equal to 2,000. So there's 2,000 words in his story, and if we multiply that by 0.013, the relative frequency of a spelling mistake, if we times that by the number of trials, how many words he's written, that'll tell us how many successes, in other words, how many spelling mistakes it'd be. So 0.013 times 2,000 is equal to 26. So he spelled 26 words incorrectly. So 26 words spelt incorrectly. And that's for the entire story. Okay, now if we have a look at this, we want to find what percentage of the 1,600 words that he wrote on Sunday were spelled correctly. Now we know for the first 400 words that 8 of them were spelled incorrectly. And we know for the entire story that 26 words were spelled incorrectly. So if we do 26 take away 8, that'll tell us how many words are spelled incorrectly on Sunday whenever he wrote that 1,600 words, the rest of the story. So 26 take away 8 is equal to 18. So let me see, he spelled 18 words incorrectly on Sunday. Okay, so if he spelled 18 of the words on Sunday incorrectly, that means the rest of them must be spelled correctly. And he wrote 1,600 altogether, so if we take away 18, that'll tell us how many words he spelled correctly. So 1,600 take away 18 is equal to 1,582. So that means he spelled 1,582 words correctly on Sunday. So the question said, what percentage of the 1,600 words on Sunday were spelled correctly? Well, as a fraction, it'd be 1,582 out of the 1,600 words. That's the fraction of words that he spelled correctly on Sunday. And if we write that as a decimal number, so 1582 over 1600, that's equal to, as a decimal, that's equal to 0.98875. And then if we write that as a percentage, just times by 100, that would be equal to 98.875%. So that means that Edward spelled 98.875% of the words on Sunday correctly. And that's it. Okay, so just to recap in this question, we were told that he wrote 400 words on Saturday, and the rest of the story, the 1,600 words, on Sunday. We wanted to find the percentage of these words on Sunday that were spelled correctly. So what we done was we started off by taking the entire story, the 2,000 words, and times that by 0.013. And that told us that Edward spelled 26 words incorrectly over the whole story. 8 of those words were spelled incorrectly on Sunday. So that means the rest of them, the 18, were spelled incorrectly on Sunday. That means of the 1,600 words that he wrote on Sunday, the 1,582 of them were spelled correctly. We wrote that as a fraction, and then changed that to a decimal, and then to a percentage, and that's the percentage of words that he spelled correctly on Sunday. Okay, let's look at our next question, question number 19. So question number 19 says, a spinner lands on green 700 times, and the relative frequency of a green is 0.35. And the question says, write down the number of times the spinner was spun. Okay, so normally whenever we're doing a question like this, we would take the relative frequency, 0.35. we'd multiply that by the number of trials, in other words, the number of times the spinner was spun, so we'd multiply by a particular number, and then the answer would be the number of successes, which in this case would be 700. So we know that 0.35 multiplied by the number of times the spinner was spun will be equal to 700. So that's fantastic. We can now work out this number, the number of times the spinner was spun. Because obviously if we know that 0.35 times this number is equal to 700, if we do 700 divided by 0.35, that'll tell us this number. So 700 divided by 0.35 is equal to 2,000. So that means the spinner was spun 2,000 times. And you can check that if you do 2,000 times by 0.35, that's equal to 700. And that's it. So the number of times the spinner was spun was 2,000. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on relative frequency. If you need any extra help on relative frequency, if you go to the videos and worksheets section of the website and scroll down to video number 248, there's a dedicated video tutorial there on relative frequency. Alternatively, you could scan this QR code. But in this video, we focused on the video solutions to the practice questions. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. Also, if you know anyone that needs any extra help with their maths, please recommend the Corbettmaths resources to them. The Corbettmaths resources might be able to help them with their maths, and that'll be great as well. So thanks so much. Cheers. Bye.